Hello, hello. I am audible. Yes, right. So, आज we will talk about skewness. Okay. In previous classes, we talk about measure of central tendency, measure of dispersions. Now we move to measure of skewness. So, in previous classes, we have said that measure of central tendency. So, measure of central tendency, we find the average value of given data. In central tendency, see, we find here measure the central value of given data. So in central tendency, find the central value. In measure of dispersions literally it means find the scatteredness. That means literally it means a scatteredness, means a spreadingness. Okay. So in dispersions we find the scatteredness of data. That means measuring the scatteredness, measuring the scatteredness of distributions. Now we move to measure of kurtosis, skewness and kurtosis, skewness and kurtosis. Okay. So here skewness represent the asymmetricity. Skewness means lackness of symmetric, lackness of symmetricity, lackness of symmetric, lackness of symmetry. Okay. And kurtosis, we measure the flatness of a curve of given data. Kurtosis, we measure the flatness of curve of flatness of curve of given data. So one by one we will study the skewness. Symmetric means when given data whose mean, median, mode are equal. Symmetric means a data whose mean is equal to median equal to mode. That means mean, median, mode are equal, then given data is said to be symmetric. Here we make the lackness of symmetricity, means asymmetric data. Lackness of symmetricity means asymmetric data. Lackness of symmetric means symmetric means asymmetric data. Metric data. So asymmetric means mean, median, mode are not equal. Asymmetric means asymmetric. Means mean is not equal to median, is not equal to mode. So mean, median, mode are not equal, then data is said to be asymmetric data. Or similarly, mean is represented by M and median is MD or mode is MO. So here M means mean, MO means median, then MO means mode, and MD means median. Is it clear? So symmetric, asymmetric. So in a skewness we measure the asymmetric data. Okay, next move. Okay. So for asymmetric data, metric data, mean minus mode equal to 3 times of mean minus median. There is relation median. Okay. Generally we draw the symmetric for symmetric data. We move this. Okay. Okay, x-axis. This is y-axis. Okay. So f of x. So symmetric data for symmetric metric, mean is equal to median equal to mode. So for symmetric data, these are the symmetric data. Or for asymmetric, it may be positive left, it may be negative left. Okay, negative left. Positive skewness, positive asymmetric, positive asymmetric, or negative asymmetric, asymmetric. Okay, so in positive symmetric, mean is greater than median or mean is greater than mode, and in negative symmetric, mean is less than median and mean or mean is less than mode. So in negative symmetric, it is tail is towards as a right and it towards left, and positive asymmetric tail is towards right. Okay. Now how to calculate the Carl Pearson's give the formula to calculate the skewness of asymmetric data. So according to Carl Pearson's, a skewness, measure of a skewness, it is denoted by SK. So SK is nothing but mean minus mean minus mode, or similarly we can, if as a mean, median, mean and mode is given, so measure of a skewness is mean minus mode, and if mean and median is given, the mean minus median, 3 times of mean minus median. A skewness is 3 times of mean minus medians. According to Pearson's coefficient of a skewness, coefficient of a skewness, coefficient of a skewness, Pearson's mathematicians, biostatisticians, British biostatisticians, they developed lot of relations, give the lot of theories in statistics and as well as mathematics. So Pearson's coefficient Sk is denoted by mean minus mode divided by a standard deviation, St, a standard deviation. So it can be written in such a form: mean minus mode divided by a small sigma, standard deviation. When as a mean and median is given, according to Pearson's Pearson's coefficient of a skewness, so 3 times of mean minus median divided by a standard deviations. So these are the formula for calculating the coefficient of a skewness according to mean and mode, according to Pearson's. Okay, next move. Okay, now move to kurtosis. Kurtosis, nothing but kurtosis measure the flatness of curve of the given data. Flatness of curve of given data. Okay, which type of curve is? Suppose sometimes curve is in normal situations, sometimes curve is in very peak situations, sometimes it's very low situation, low types of curve. So okay, this is y-axis. Okay, so in a low, this is a kurtosis. Okay, and in a normal form, normal curve, this is said to be mesokurtosis. And third one is high leptokurtosis. So measure of that means more pickedness. सबसे ऊंची चोटी जिसको बोलते हैं, जैसे लेप्टोकुटोसिस बोलते हैं. लेप्टोकुटोसिस, प्लेटो मीन्स मोर फ्लैटनेस, ज्यादा फ्लैट हो, एंड मेसो मीन्स नॉर्मल फ्लैटनेस ऑफ द, ए मोर फ्लैट मीन्स मोर फ्लैट, ज्यादा है जो झुका हुआ ये है, और ज्यादा पिक्ड हो उसको लेप्टोकुटोसिस करते हैं. तो एक हाउ टू मेजर द in numerical form, how it is measured, calculated, इसको हम कैसे फाइंड आउट करेंगे. सो नथिंग बट coefficient of kurtosis is represented by B4 upon B2. Okay, so B4 क्या होता है? That means कि fourth moment So one by one we recap all those things. First moment represent the mean, second moment represent the variance, standard deviation, ठीक है, okay. Third moment represent the lackness of symmetricity, and that means askewness. Third moment represent the askewness, and fourth moment represent the kurtosis. So these are the first moment according to that, and this is said to be beta 2, and according to another formula for finding the kurtosis is, it is represented by beta 2. So and another formula is gamma 2 is represented beta 2 minus 3. These are these two formula, okay, to finding the kurtosis. One by one we represent this. So first moment here, mu1 means first moment represent the central value, and second moment represent the second moment represent the deviation of the data, represent deviation या आप इसको बोलते हैं डिस्पर्सन्स भी बोल सकते हैं, ठीक है ना, ओके. डिस्पर्सन okay, of data, okay. And third moment represent the askewness of data, and fourth moment represent the fourth moment represent the kurtosis of data, kurtosis of data. So one by one we give some example, we take the example and find this, okay. These are the basic concept, okay. We take some examples and solve this, okay. We have some questions. I am taking this. Wait. In download. So one question is, okay, you take one questions. Carl Pearson coefficient of skewness is 1.2, its mean is 164, and mode is 100. Find the standard deviations. Question is that find the standard deviation, find the a standard deviation sigma, small sigma, ठीक है, if Pearson's coefficient of skewness, Pearson's coefficient of skewness, Pearson's coefficient of skewness is given. Skewness is 1 to 1.28 and its mean is 164 and mode is 100. Mode is 100. These are the questions. So अभी देखे हैं कि according to Pearson's coefficient, Pearson's coefficient of skewness, हमने क्या देखा है, दो फॉर्मूला निकाले थे, इसके इक्वल टू मीन माइनस मोड बाय स्टैंडर्ड डिविएशन, और दूसरा क्या था, यू राइट स्टैंडर्ड, ओके, मीन erase this, mean minus mode divided by standard deviation, standard deviation. दूसरा क्या था, 3 times of mean minus median divided by standard deviation. These two formulas. So here mean and mode is given. So that's why skewness is given. Pearson skewness is 1.28, implies that 1.28 equal to mean is 164 minus 100 divided by a standard deviation. So we have to calculate the standard. Calculating this, so difference is 1.28. Convert into the decimal. So you remove this. Whenever you remove the decimal, so 1.2 divided by 100. Wait, 1 minute. So okay. So a standard deviation nothing what? A standard deviation क्या आ जाएगा? Difference this, the 64 into 100 divided by 128, or this is 64 2 times is 128, 2 times is 100, so this is 50. So a standard deviation implies that 50. So whenever in these relations 1 2 3 4, so 3 terms is given, you have to calculate the fourth term. So these are the process, simple questions for calculating the finding the if 3 terms are given, finding the fourth term. So here 3 terms, Pearson's coefficient, mean and mode is given, we have to find the standard deviation. So simply you applying the formula, you know the formula, and easily you can calculate this. So this represent the skewness. Simply this is the measure of asymmetricity. Data is asymmetric, that means ki mean, median, mode are not equal. If equal, they are equal, that means kis data is symmetric. Symmetric means left right cover each other. When flip this, when fold the data, then left is equal to right, just say palm. So these are symmetric, left and right palms are symmetric to each other. So data is same like this. We fold, that is whole data. And in next topic we will start with new topics, that means regressions, regressions, yes, okay. and interferential statics we will discuss. Yeah, linear regressions, linear regressions. Thank you.